Here's a question that haunts nuclear engineers. What happens if you drop a nuclear bomb on a nuclear power station? Most people think they know the answer. The explosion, obviously a mushroom cloud, the destruction multiplied by the radioactive fuel inside. But what if everything you just imagined is wrong, and I mean catastrophically wrong? Let's consider scenario 1, the seismic theory. Here's what the model shows. Underground nuclear tests don't just displace rock, they fracture fault lines. The energy released by a strategic nuclear weapon, measured in kilotons, travels through the Earth's crust like a shockwave through glass. In 2013, North Korea conducted an underground test. Seismographs registered a 5.1 magnitude earthquake. The test site collapsed. The ground moved. Now imagine the same energy released beneath a coastal nuclear facility. Not a test tunnel in mountains. A reactor complex sitting on sedimentary rock, saturated with water. The bomb hits. The shockwave fractures the crust beneath the facility. Fault lines that have been locked for millennia, they shift. The ground doesn't just shake, it tears. Tidal surges follow. Ocean floors don't move gently. When the seabed displaces, waves radiate outwards at hundreds of miles an hour. Coastal reactors already stressed by the blast are swamped, not by water, by the earth itself. And here's where it gets worse. The crust isn't just cracked, it's destabilised. Remove enough structural integrity from the right point on a tectonic plate and the mathematics become grim. The surface doesn't slide, it implodes. The weight of the overlying rock, miles of it, collapses inwards. The reactor doesn't just burn, the ground swallows it and everything beneath it. No crater, no debris field, just a hole in the world where something used to stand. That's scenario 1 and it's not even the worst one. Scenario 2, the chain reaction extinction. This one doesn't end at the blast zone. It starts at the reactor. The bomb breaches containment, but here's what most people miss. A nuclear facility just doesn't have one reactor, it has multiple, and neighbouring facilities share the same groundwater systems. The contamination leaks into the aquifer. That aquifer feeds rivers, and rivers feed reservoirs. Reservoirs feed agricultural zones, and before you know it, the contamination has moved through the water table like a slow motion poison. But the water table isn't the only vector. Spent fuel pools sit exposed, uncooled, vulnerable. When a facility loses emergency power, those pools become the chain reaction waiting to happen. This isn't speculation. After Fukushima, nuclear agencies worldwide identified cascading failure as the primary nightmare. One reactor failure leads to another. The spent fuel pools, uncooled, exposed, become the vector. Radiation particles don't stop at borders, they go into the atmosphere. Prevailing winds carry them across the continent. Rainfall scrubs them from the sky and deposits them into soil, into crops, into livestock. Food chains begin to fail, not because of one disaster, because of a slow accumulation across an entire hemisphere. Now the atmospheric argument. Trace radioactive particles accumulate in the upper atmosphere. Iodine-131, cesium-137 and strontium-90. Each one has a lifespan measured in decades. Solar radiation begins to interact differently with a contaminated upper atmosphere. Weather patterns shift. Precipitation becomes unreliable. Growing seasons contract. Not immediately, over years, but when you're looking at the food supply of billions of people and you've destabilised the agricultural zone of 3 continents, the mathematics stop being theoretical. Planet death, not in a flash, in a slow, grinding, undeniable collapse of the systems that keep us alive. Those are the two scenarios: seismic destruction or chain reaction extinction. Here's the problem, both of them are wrong. April the 26th, 1986, reactor number 4 at Chernobyl detonated. Not a nuclear explosion, a steam explosion, followed by a graphite fire that burned for 10 days. That fire became a chimney. It pulled radioactive material up into the atmosphere and spread it halfway across Europe. Chernobyl released 60 times more radiation than the Hiroshima bomb. The exclusion zone is over 1,000 square miles. 60 years later, it's still uninhabitable. Near Fukushima, March 11, 2011. A 9.1 earthquake, a 50-foot tsunami, the backup generators drowned without cooling the reactor, cores overheated. But here's the twist nobody saw coming. It wasn't the reactor that almost killed everyone, it was the spent fuel pools. Pools where used fuel rods cool down, lose the water and they catch fire. Hydrogen gas builds up, then it explodes. Fukushima released 1/5 of Chernobyl's total radiation, and those spent fuel pools nearly sent contamination directly into the Pacific Ocean. 3 Mile Island, the one that went right. The containment vessel held, radiation release was negligible, no one died, the surrounding area didn't become a ghost zone. 3 Mile Island proved containment works. When it's built right, it does the job. So here's what actually happens when a bomb hits a nuclear station. The containment building, designed to withstand internal pressure, not a direct nuclear blast, is obliterated. The reactor core is exposed, nothing between the fuel and the sky. The spent fuel pools catch fire, the same phenomena as at Fukushima. But now there's an active nuclear explosion on top of it. Explosions and heat lift radioactive material into the upper atmosphere. Prevailing winds carried hundreds, potentially thousands of miles. Fallout settles, cesium-137, strontium-90 and plutonium, all of it now airborne. Here's the number. If 100% of the cesium-137 in a typical reactor is released, it could render over 2,000 square miles uninhabitable. That's an area larger than New York forever. Well, not forever. In radiation terms, forever means 30 half-lives of cesium-137. Each half-life is 30 years. You're looking at 900 years. Yes, 900 years before the land is truly safe again. One bomb, one target, you don't get a bigger explosion. You don't get earthquakes or chain reactions or planetary death. You get the worst nuclear disaster in human history multiplied. Chernobyl plus Fukushima, happening simultaneously at one location. The same nightmare concentrated. We lied to you both times with the scenarios. But the truth is worse, not because the physics surprises us, because it delivers the same horror we already knew, just faster and in one place.